Yes, I guess we can start. First of all, thank you for joining us today, dear Hari, Fuat, and Utku. It's a great pleasure to host you here in this great panel of ours about 5G technology and the impact of 5G on our lives and ways of doing business. It's great pleasure, and I welcome you on behalf of TÜSİAD and its board members and TÜSİAD members. If you don't mind, I will do my speech in Turkish, so that we have audience from the press and media so that they can understand. Değerli konuklar, kıymetli basın mensupları, 5G teknolojisi hayatımıza ve iş yapış biçimlerimize etkisi temalı etkinliğimize hoş geldiniz. Sizleri TÜSİAD Yönetim Kurulu adına saygıyla selamlıyorum. Covid-19 pandemisi kuşkusuz süregelen dijitalleşme rüzgarını daha da hızlandırdı ve önceliklerimizde köklü değişikliklere yol açtı. Pandemi mevcut işlerin devamını sağlamak, müşteri ve çalışan etkileşimini canlı tutabilmek amacıyla her yerde güvenli, kesintisiz, sürdürülebilir ve yüksek kaliteli dijital altyapı ihtiyacının önemini çarpıcı bir şekilde gözler önüne serdi. Yeni nesil kablosuz teknolojiler, daha hızlı bağlantı ve artırılmış veri kapasitesi sektör ve ölçek fark etmeksizin hızı rekabetin merkezine oturttu. Basit bir örnekle 5G teknolojisiyle bir HD filmin 5 ila 10 saniye arasında indirilebileceği, öte yandan 4G için bu sürenin 10 dakikaya karşılık geldiği belirtiliyor. Burada ana unsur film olsa da aslında bu yüksek kapasiteli dosyaların bir yerden diğerine ne kadar hızlı aktarılabileceğini gösteren çarpıcı bir örnek. Hiç şüphesiz ki 5G teknolojisi yenilikçi çözümler sunuyor. Artırılmış veri kapasitesi ve yeni nesil kablosuz teknolojiler endüstriler için yenilikçi kullanım senaryolarına olanak tanıyor. Her geçen gün hızla değişen müşteri taleplerine karşılık kişiselleştirilmiş müşteri deneyimi sunulmak amacıyla IoT sensörlerinden ve veriden faydalanılıyor. İlaç teslimatı yapan hastane robotları, uzaktan cerrahi, gerçek zamanlı trafik izleme optimizasyonu, teslimat dronları ve çok daha fazlasıyla gelişmiş kablosuz teknolojiler uçtan uca bir bağlantı zinciri sunarak yapay zeka, nesnelerin interneti, büyük veri analitiği başta olmak üzere yükselen teknolojilerin bel kemiğini oluşturuyor. Gartner, 2021 stratejik teknoloji trendlerinden biri Anywhere Operations olarak açıkladı. Bu model çerçevesinde müşterilerin, işverenlerin ve iş ortaklarının mekandan bağımsız olarak faaliyetlerinin kesintisiz olarak sürdürebilmesinin altı çiziliyor. Dolayısıyla endüstriyel iş modellerinin dönüşüm sürecinde 5G teknolojilerinin entegrasyonu olmazsa olmazlar arasında yer alıyor. Değerli konuklar, hiper bağlantı çağında ağa bağlı cihazların sayısının 2023'e kadar 29,3 milyara ulaşabileceği öngörülmektedir. Ki bu oran kişi başına 3'ten fazla cihaz anlamına gelmekte. 5G teknolojisi makine ve araçların bağlanabilirliğini artırarak otomasyonu çarpıcı bir şekilde hızlandıracak. Dünya Ekonomik Forumu tarafından yapılan bir araştırmaya göre sosyoekonomik büyümenin katalizörü olarak 5G'nin 2035 yılına kadar küresel ekonomik değerinin 13,2 trilyon dolar olacağı öngörülüyor. Dijital altyapının stratejik önemi Avrupa Birliği'nin yeni büyüme stratejisi kapsamında da yakından takip ediliyor. Avrupa Komisyonu tarafından geçtiğimiz aylarda açıklanan AB'nin 2030 yılı için dijital pusulası kapsamında her yerde 5G ve herkes için gigabit bağlantısının sağlanması hedefleniyor. Strateji aynı zamanda 10.000 iklim nötr, yüksek derecede güvenli edge, uç noktaları ve oluşturulmasını ve AB'de düşük gecikmeli veri erişimi sağlayan bir dağılım yapılmasını amaçlıyor. Değerli konuklar, 5G'yi sadece fiber altyapı olarak düşünmek, konuyu stratejik açıdan eksik ele almak olur. 5G teknolojilerinin gelişimi, gelecekte sosyoekonomik büyümenin ve dolayısıyla ülkelerin rekabet gücünün en önemli bileşenlerinden birisi haline gelmek üzere. Kaliteli veri ve teknik altyapıya erişim imkanlarının genişletilmesi ancak güçlü bir dijital altyapının tesis edilmesiyle mümkün olabilecektir. 5G teknolojisinin doğru bir şekilde geliştirilmesi ve altyapı yatırımlarının yapılabilmesi için bütüncül politikaların hayata geçirilmesi son derece önemli. Bu amaçla kamu ve iş dünyası arasında güçlü bir sinerji ile gerekli yatırımların yapılması için adımlar atmalıyız. Sözlerime son verirken bugün etkinliğimize katılan değerli panelistlerimize teşekkür ediyorum. Alanında uzman konuşmacılarımızın bilgi birikimlerinin ve tecrübelerinin ufuk açıcı olduğuna inanıyorum. Keyifli bir etkinlik olmasını diliyor. Sözü TÜSİAD Yazılım Çalışma Grubu Başkanımız Sayın Utku Barış Pazar'a bırakıyorum. Sizleri sevgi ve saygıyla selamlıyorum. Utku Bey buyurun. Söz sizde.
Serkan çok teşekkürler. Ben müsaadenizle konuşmama bundan sonra İngilizce devam edeceğim. For the interest of our guests, I'm now switching to English. First of all, welcome to the first episode of TÜSİAD Digitalks series hosted by TÜSİAD Digital Turkey Roundtable. In these sessions, what we'd like to do is actually talk about key topics around digital transformation around the globe, together with global subject matter experts. And we discussed and we thought that 5G would be a great start for the inauguration of our digital series. And today we picked 5G technology, the impact of 5G on our lives and the ways of doing business. And I'd like to keep the session as interactive as possible. I will introduce the guests later on, but I kindly request all the participants, listeners, to ask their questions freely during the session as well. I try to respond to those questions during the session as much as possible so that we don't do like a normal presentation, then a Q&A session, but it will be a more interactive session, hopefully. Today, to discuss about 5G, we have very, very prominent guests, Fuat Siddiqui and Harry Holma. I know from my telco background, these two gentlemen are renowned globally. But in the interest of time, I would like to hand over to first microphone to Harry, and I will ask him to introduce himself. Harry, welcome again.
Thank you, Serkan. Thank you, Utku. Thank you for the invitation here. Happy to be here, and welcome, ladies and gentlemen, for the session. So, indeed, my name is Harry Holma. I'm part of Nokia, based in Finland, and part of a Chief Technology Office team in our organization, and mainly focusing on the radio technologies. So I have background in 3G, in 4G, in 5G, and of course soon we are starting the next generation work. So indeed happy to discuss with you today about the 5G capabilities and 5G evolution.
Harry, thank you very much. It's great honor to have you here today with us. You know, back in the day, I used to read your books about different radio technologies. So I feel really privileged to host you here today. Next, we also have Fuat Siddiqui from Nokia Bell Labs. Before Fuat introducing you, I want to talk also about Bell Labs just a little bit. When we visited the Nokia premises last year in my last trip to Finland, I was quite positively surprised by the number of Nobel Prizes that Bell Labs acquired actually over the years. So if you don't mind, while you're introducing yourself, if you can briefly touch upon the life at Silicon Valley and what Nokia Bell Labs is about.
Absolutely. Thanks, Utku. It's again delighted to be here and a pleasure to speak at this panel. Yeah, indeed, I think on a Bell Labs level, it's been a very, I guess, instrumental organization throughout the last 90 years in its history. And you talked about the Nobel Prizes. My previous boss used to say that we are the most accidentally lucky organization in history because we keep winning these prizes, but it has never been about the prize itself, because Bell Labs' main charter has always been to solve the biggest human industrial problems. And while you're looking for those solutions to solve for the human need problems, you win these prizes. So I think the last 90 years has been really rich. We've developed the transistor, the C programming language, pretty much every foundational technology that is fueling the internet today. So it's really an interesting place. I represent the consulting arm of Bell Labs, and what we do is, as Harry and the researchers are looking 10 years out and thinking about what the future of technology holds, my team looks at computing the economic and the social impact of that and predict what the future would look like. So that's part of my job into thinking and predicting the macro future. And the second part of my job there is to also offer consulting and advisory to customers in enterprise segments and telco segments, because while we are predicting and thinking ahead, we want to make sure that we are able to help our customers transform to this end state view of ours so that the reality of the markets could be well mapped and we can modulate that. So pretty interesting times. A lot of things are happening in the industry, and delighted to get into the conversation and answer any questions you may have.
Well, thank you very much. Very pleased to have you here as well with us. So let's get going. Let's start with 5G, okay? We hear about this term 3G, 4G, 5G, but what is 5G? Let's start with the basic question. What should we understand when we say 5G?
Yeah, so good point. So let me maybe explain some background here about the technology and why 5G has been done and what are the targets and the capabilities. So indeed, if you look at back in the history, then we used to have a new radio generation roughly every 9 or 10 years. I mean, 3G was starting 2001, 4G LTE starting 2010, and then 5G started roughly 2 years ago, 2019. So, and in terms of radio, 5G is a new radio solution. And the first phase in 5G deployment today in the commercial network is mainly about mobile broadband. So the very first phase is to provide more capacity, more data rate. Typically, we can see 5 to 10 times higher data rate compared to 4G networks. We can see up to 10 times more radio capacity being provided. The main solutions we need for delivering better performance has been usually new spectrum. New spectrum is needed. We can discuss that in more detail later today. And then also new RF and antenna technology is quite important. So we need quite heavy R&D investment in terms of providing these new 5G radio capabilities. And the first phase of 5G is actually targeted for fairly simple upgrade on top of 4G network. The idea has been that 5G is something which is sitting on top of a commercial LTE 4G network. The idea is that mobile operators can use their existing base station sites. They can use their existing transmission network. They can use their current 4G protocols, and they can use also their existing 4G packet core network. And by doing that, they can still provide substantial boost in the radio capabilities. In practice, what we can see in performance, the data rates are peak data rates, typically around 1 to 2 gigabits per second. I did some practical speed testing just recently in the commercial network in Helsinki, in the capital in Finland, and the peak data rate was around 1.2 or 1.3 gigabits per second. So that is where we are mainly today, but that is only the very first phase in terms of 5G capabilities. The target is far beyond that. 5G is not only supposed to be a new radio with faster capability. 5G target is to provide a number of new service capabilities. And that is something which is exactly right now starting in terms of practical deployments. And what we mean by new services is for example, low latency capabilities. It is ultra reliable communication. Those capabilities are quite important if we want to run some new services, let's say like remote control services on top of mobile networks. Also, things like slicing will make it possible to provide better quality on some customer segments or some applications while using the very same network. A very practical example is for example, public safety operations are now starting to run on top of mobile networks, of course, with a higher priority. And the second phase requires also some new technologies. For that, we need to have new packet core network, 5G core network. We typically need to have different network architecture. We need to bring capabilities to the network edge. We can discuss the architecture in more detail also today. And also we need to have some new spectrum options. Typically, the first phase in 5G started on the mid-band TDD. In Europe, typically 3.5 gigahertz spectrum band. But now later, when we go forward, we need to also have low frequencies, so-called FDD, frequency division duplex frequencies, in order to provide great coverage. And we also need to have even higher frequencies, so-called millimeter wave frequencies, in order to provide even higher data rates, even higher capacity for the local deployments.
Maybe
and indeed,
if you can touch upon this frequency and the auction aspect and global rollout, because the audience might not necessarily know these frequencies in their day-to-day activity. But like, for example, in Turkey, we don't have the 5G auction yet. So we don't know where the frequency will be, but there are some discussions about it. But if you can maybe pause and expand on it a little bit, that would be great.
Good point. I mean, spectrum, of course, is the key for any kind of radio deployment. So that is a good point. So typically, in many other cases, the first spectrum has been mid-band. That is typically 3.5 gigahertz band or 2.5 gigahertz band, because there is quite much spectrum available in most European countries, up to 400 megahertz in total, which means in practice that for one individual mobile operator, the spectrum allocation is typically up to 100 megahertz. And by using so much spectrum, that of course provides you the capability for extremely high data rate and high capacity. 5G is designed to support also many other spectrum bands. That is only the starting point. And we already see today in many markets that 5G has been deployed on the lower frequencies, could be 700 megahertz, could be 2.1 gigahertz, could be 1800. And the idea is that we are starting to, you could say, refarm or reuse our existing 4G spectrum for the 5G deployment. And why is that? The motivation is mainly that by bringing 5G technology on the low frequencies, you can make coverage better. Because you know that when you go lower frequency, your signal propagation is better, so you can provide better coverage. And the 5G coverage is becoming quite important once we want to enable some new services. I mean, reliable service, of course, requires that we have coverage available. So that is kind of these main two spectrum blocks today is the mid-band TDD, and it is spectrum refarming on the FDD spectrum. And if you look at from device point of view, then most of the devices today do support those two spectrum of options. If you buy any of the new 5G devices, FDD and TDD spectrum indeed is supported today. And if you ask then the global deployment status, then the very first commercial 5G network started in Korea, in South Korea, and that was April 2019. So we already have slightly more than 2 years of commercial 5G deployment running. And Korea today has already more than 50% of the mobile data running on top of 5G network. And the device penetration, I think, is around 25% or so. So in Korea already kind of migration to 5G has been extremely fast, and that of course will happen eventually also in other markets as well.
So Hari, if I summarize, you mentioned about what 5G will bring is capacity, speed, low latency, and better energy consumption. You mentioned about edge computing. I'll dig deeper into that, but I want to ask a simple question. But before doing so, I want to rephrase a paragraph from A.T. Kearney, one of the prominent consulting companies. That's how they are describing 5G. The telecom industry race for 5G is one of the most intense and consequential technological contests of our time. So it's very bold sentence. It says major economies around the world are working aggressively to develop large-scale, reliable 5G coverage as future economic competitiveness depends on it. So looks like there is a greater, this is not about just the radio technology, but there is a greater transition that people are discussing about. So I want to ask, what is it? You know, what is the implication?
Yeah. No, I think they make a good point, and I think as Harry tried to touch, I think, and you said, Utku, it's more than a radio technology. It's the end-to-end construct around what you will see in the 5G era is that the devices, the applications, the cloud ecosystem, and the network are all coming together, and they will reside at the edge. And that's where all the action is going to happen. So it's going to be highly distributed, highly local, highly software centric. And therefore you can imagine the implication of that. But let me try and answer this in the following way, because I think it's important for your audience to take a little bit of stock from the past, because sometimes you need to look a little bit backwards and see what has happened in the past. And then you got to be bold enough to imagine a bigger and brighter future. So let me take you a little bit in the past, and if I draw your audience to the point where we had the first and the second industrial revolution. And that was a time where we had massive productivity growth happen. So if I use the data from the United States and it applies globally, 1950s was the maxima where we hit the highest productivity growth rates. And it happened at the back of the first and second industrial revolution. But what exactly happened then? What happened is we built physical networks. We built physical networks to move physical goods, transportation networks, health networks, communication networks. All these networks were built in a way that they diffused and adoption happened to a certain point, and then they create an aggregation effect, and sectoral and intersectoral growth happened at the back of it. But then, and that resulted in serious human growth, social growth, economic growth, and the data is there. But ever since the point of the third industrial revolution, or internet age so-called, all the investments that we made in ICT, the productivity growth rates have been diminishing ever since. And it's alarming because we have put all this infrastructure, but it hasn't resulted in the sort of boost. And I think, and then we were reflecting on this. So what is the reason for that? And this is just prior to the pandemic, because in Bell Labs, we have been vigorously talking about the fact that we've built this intelligent infrastructure, but it hasn't really brought us the productivity growth that it needs. And what we figured out, and this is just the pre-pandemic, because we have only digitized 30% of our industry sectors, meaning that the sectors like finance, media, journalistic services, e-commerce, we did a little bit of investments in that, but the 70% contribution to GDP comes from these enterprise industrials like manufacturing, supply chain, logistics, warehouse, government, you name it, and they employ 75% of the workforce. They only received 30% of ICT investments. And this is just prior to the pandemic. And then we were sort of distracted a little bit in doing things which were mostly consuming trivial entertainment. We put consumer in charge. We were doing advertisement-based business models. We were living in the time of the selfie, right? The selfie era, the Snapchat era, and it hardly helped any nation move the productivity needle. And then came the COVID. And what COVID did was it exposed exactly what is actually at stake. Thankfully, the investments that we have made in that digital infrastructure, we were able to pivot those e-commerce. It shot up dramatically all those human needs that were able to order online for those really sensitive needs of the population. 3 months in the US, what we saw in 3 months didn't happen in the last 10 years. Telemedicine, what skyrocketed. We did a lot of these online services thanks for just that 30% investment we made in those sectors. But what it exposed is that 70% sector, we were not able to pivot. Imagine in the early days of the pandemic, the manufacturing sector had the deficiency. They couldn't do the adaptive or additive manufacturing so that they could produce ventilators or masks on demand in very frequent ways. So then what we said is this is where the future of 5G will have to come, because you have to invest in a 5G enabled supply side infrastructure. So remember the first and second industrial revolution, we had that physical networks we built. Now we need to digitally inoculate those physical industries by the power of the underlying 5G networks. And once you do that, you're going to drive a new level of productivity in the markets. And that's why this quotation that you were talking about is this transformational impact of 5G is indeed profound, because you can change the productivity and the resiliency of all those sectors, because we have just touched the surface of the sectors by digitizing only those sectors which is represent 30% of a world GDP. Now you need to invert the paradigm by investing in a sector which deploys 75% of a workforce and has 70% contribution to the GDP. So you see how big the promise is of the future.
But I will ask you to expand on this with some more concrete examples for industries later on. But before doing so, I want to ask Harry, in terms of technology, you mentioned about the throughput and latency and so on, but I remember a good old discussion with one of the very prominent global mobile network CEO. Back in the day, I was talking about the 3G, how it's going to increase the speed and stuff like that. And he basically nodded his head, listen. And then he said, how am I going to make money with it? That was an operator perspective, of course, but from a technology perspective, what is going to be new that will enable different use cases? Like we're talking about IoT, autonomous cars, remote operations, things like that. What is it that, you also mentioned about edge computing. What is it that will enable these things? What should they expect big bang from 5G?
Indeed, so the whole underlying technology design is quite different compared to 4G. So 4G basically was designed, and 4G has been utilized for the consumer services, so mainly entertainment. I mean, video is one of the main applications customers are using today on top of 4G networks. But those services typically are not kind of like critical services. So people use it mainly for entertainment, for their private life. But now the main thing changing now in 5G is that the networks we are building and designing need to be completely on the different level in terms of reliability, because it's not only entertainment, but it is also critical communication which will be running on top of those networks, because those networks are controlling factories, they're controlling traffic, they're controlling smart cities. And that is the underlying reason why the network design and the network deployment has to be different compared to what we had in the 4G timeframe. And that is actually explaining why some of the underlying technologies in terms of like protocols, in terms of architectures, need to be different, because we need to have solution for providing the better reliability, and we need to have solution for providing low latency on the radio as well.
So, like, for example, I'm curious about autonomous cars. You read about the level 4 autonomy, and I read somewhere that without 5G, it's not possible. So what's about 5G that will make, for example, autonomous car possible?
Well, I mean, maybe not always, not autonomous car only, but you could say, like, for example, any kind of remote control activity. So there will be many kind of machines, or maybe not cars, but many other type of machines which you may want to control remotely. And typically what is critical for the remote control is that the radio connection has to be reliable, of course. And secondly, because it's interactive things happening, you need to react something happening. So for the reactions, the reaction times or the latency has to be quite low. And that is why you can see so often in the network design discussion about ultra reliable and low latency communication, because those two capabilities are quite critical so that we can truly provide the new services on top of the new mobile networks. And then, of course, if you look at the practical deployment, you could say there are two options for providing the solution. You can use the wide area networks provided by the mobile operators, and you can provide certain piece or slice out of that for the critical communication. The other solution is that there will be a local private or local dedicated network, and Nokia already is trialing some of those capabilities also with the Turkish customers in terms of like providing local reliable radio connectivity. Globally, Nokia has already more than 100 4G-based local private networks being deployed. And one example has been, for example, airports. The motivation for the private network has been that they want to have reliable radio connectivity. Wi-Fi is not good enough, and LTE 4G has been the solution so far. But they want to have their own network for security reasons, because they want to keep the data in their premises. And that is kind of the starting point also for the private 5G networks in the future as well.
I'll expand on this private networks later on, Harry, but I want to ask Fuad a follow-up question based on the previous discussion. But you mentioned about the impact on sectors. Maybe we can pick a couple of sectors and start discussing. You mentioned logistics. What should I envision in terms of logistics with 5G? And if you can elaborate why it's not possible today, is it costs? Is it something else? And why it's going to be possible with 5G?
Sure. I think a couple of things are happening. I think as we discussed, the physical industries that require now this massive transformation, which is the next phase of 5G, they are now beginning to look at some of the requirements and specifying those requirements to the 3GPP in terms of Release 17, Release 18 requirements, which means that these guys who are running operations technologies, meaning the stuff that runs the physical world, the factories, the warehouse, the transportation networks. And for the first time, now we are looking at the collision of operations technology with IT technologies. And that is the big opportunity that is opening the door for these physical industries to now look at adopting them. Because in the past, we in the mobile industry were not ready enough with the previous generation, as Harry was talking about, with the advancements of the new generation of 5G, we can now hopefully in a better position to satisfy the stringent security reliability needs. So give you an example, in the mobile network space, we build networks that are 99.8% reliable. It's a pretty super good mobile network, but you still get this often call drop, which is irritating for you. But imagine in the mission critical industries, if there is some sort of a call drop of that nature happens, you can actually have a pretty consequential effect if in terms of controlling a machine that you're trying to control. So these guys are looking at 6.9 reliability. So suddenly you have to build networks which are 6.9 reliable. But let me give you an example. I think you talked about logistics. It's a very interesting sector because it drives a lot of sectoral and national growth as well. Because starting, let's say, take a Turkish seaport, for example. If you're going to have ships coming in and out of the seaports, imagine a future where you have autonomous ships coming in, docking at the ports, and you have autonomous cranes undocking the load of the ship onto the trucks, and then orchestrating an automated guided vehicles inland towards where the warehouses is. So it's the whole end-to-end journey that you want to automate, and you can do it at the back of a 5G autonomous mobile network. And so give you an example, we were working with a customer, a very large port operator in one of the markets, and they gave us the requirements. They were looking at moving 25 million containers autonomously, which means that they were running previously semi-autonomous operation. Now they want to run 24/7 cranes. Within the industrial complex of the port, they want to have 500 trucks autonomously managed. They have thousands and thousands of sensor data. They have high definition camera. There are people communication. So you take all these requirements and you start to multiplex and see what is the effect in terms of bandwidth, latency, reliability, and security needs starts to become pretty prohibitive for traditional networks. So now you need to look at a constellation of technologies powered by 5G to drive this. And this is what Harry was talking about. You need to build an edge cloud instance with private networks that to give that mission criticality and the SLAs that you have to deliver on managing 24/7 crane operation. Because typically today, a crane can actually take 60 seconds to load and unload a container from a ship to a truck. So let's say in an hour, you're moving 30 containers. But if you have a 24/7 autonomous operation controlled with a reliable high performance 5G network, imagine the sort of the back-to-back business case. You can move and unload and load containers faster. The ships can move in and out of the berth faster. So that's great. Now that imagine that you've done that. Now you want to move your shipments from the trucking platoon inland. Now you can pack the platoons very closely, tightly integrated in an autonomous fashion, controlled by a wide area network. So now you have left the port, which is managed by a private network, into a public network. And now the 5G public network is controlling through the use of edge cloud orchestration. Now you went all the way to the warehouses where now your autonomous drones are unloading these boxes or these shipments into the warehouses, you're now using robotics control between one robot or the second robot using variable latencies. You need stable latencies to move the shipments and the products around. So imagine this end-to-end architecture that you need from a private network interworking with a public network to try to manage this thing. And as a result, what will happen? You can dramatically change the productivity levels in your logistics. So the future of industrial mobility and end-to-end logistics is all of that powered by the underlying 5G network. So that's one example that I wanted to share with you.
Thank you, Fuad. I will take it into a technical discussion, because what you described to me usually is, well, Wi-Fi is the first thing that comes to mind in managing these sensors and getting data and providing connectivity in a private domain. Wi-Fi is the first thing that comes to mind. So Hari, why is not Wi-Fi the solution, and we need a 5G network to enable the scenario that Fuad was mentioning?
Yes, indeed. Wi-Fi has been the kind of like the basic solution for the indoor connectivity at homes and offices, and it will also be in the future for those use cases like laptop connectivity. But now our studies are showing, and also many other studies are showing that if we want to provide extremely high reliability, Wi-Fi radio is not designed for that. And there are a few kind of clear underlying reasons why Wi-Fi is not the solution. One reason is that it is operating on the unlicensed band. Secondly, Wi-Fi does not have a strong radio like error coding in the transmission, and also Wi-Fi doesn't have proper mobility when you are between two different access points, and also Wi-Fi doesn't have centralized scheduling, which would allow you to control the performance. And the learning is that Wi-Fi can provide reliable connectivity only if we have a large number of access points and we can control the loading. But once we start to have more users, more customers, more devices connected, then 5G will have a clear benefit in terms of latency and in terms of reliability. And that is the reason why for the, you could say, like operational technologies, like operational use cases in the factories controlling robotics, then 5G will have a clear benefit compared to Wi-Fi. And you can already see a practical example. If you look at some of the private 4G networks that Nokia has provided, the motivation has been typically radio performance. I mean, Wi-Fi is available, it has been used, but it has not been good enough in terms of providing the radio connectivity. An airport or harbor, like Fuad mentioned, is one example. I mean, Wi-Fi radio is not designed to perform in the large areas or outdoor premises. And in those cases, like controlling some container movements, then clearly 4G or in the future 5G will be the only like solution providing like reliable enough connectivity.
Can I just simply add?
And you can also see,
sorry, go ahead.
Yes,
yeah.
Other example is that you can also see a lot of interest for the private licenses in Germany. So clearly the companies, automation companies, car manufacturers, they have applied for the local private license, which is kind of indicating that they also do believe that they will need to have the 5G connectivity for their use cases.
But you were saying something?
Yeah, I was just adding, look, you can always solve a spot problem by a certain existing solutions. The Wi-Fi and LTE is being used in many cases, but the example that I was talking about in this port cases, they actually had the vision to think a little bit future. They said, if I were to look at my targets of 2025 and beyond, and then map that towards my today's reality, what is the roadmap? Because I don't want to keep investing in technologies and upgrading. I want to build a future-proof network. And so the example that we were talking about when they gave me the number, how many cranes I need to automate, how many self-driving vehicles I need to automate. When you take all these requirements and translate that into technical requirements of variable latencies. You have to have stable latencies, etc. Because when you're moving trains, you don't want jerky movements, right? Because then it will delay the time of loading and unloading. So that's where the power of the 5G network in complementarity to with other access technology comes in. So that's where you have to roadmap. Your industries have to look at a transformation roadmap which factors in this future back perspective. And that's where then you will make the most optimal choices, not just technologically, but also financially.
Thank you, Fadi. It makes absolute sense. Maybe we can expand upon the industries. You mentioned interesting examples on the logistics. I mean, honestly, port is not the first thing that comes to my mind when you say 5G, because, you know, when we say 5G, it's cutting edge technology. So it's almost like, you know, remote surgeries, autonomous cars, all those type of things. But you talked about a very traditional industry that kind of is a little surprising for me. What else?
Well, this is why I was saying we get distracted with our selfies and trivial entertainment. We forgot the industries which has actually helped the human progress to where we are today. So now we have to digitally vaccinate those industries, which we haven't. And 5G is the vaccination for that. So let me
vaccination is a good terminology.
So let me talk about manufacturing, because it's such an interesting sector because it has a special place in many nations' psyche. So I was thinking through this, and I was looking at some of the data from the US in particular. So manufacturing as a sector represents 11% of United States GDP, 11%, and employs around 8% of their direct employment. But here's the interesting part. It has a massively big and disproportionate but positive impact to the overall global on their economy in terms of it represents and drives 30% of their productivity growth, 60% of their exports, and 70% of business R&D. Now in Turkey, compared to that, I think what I was looking at some of the numbers, instead United States, 11% GDP, you guys are roughly 19 or 20% of GDP. But your exports are around 30% and they're doing 60%. So here is the opportunity to now look at, because of the collision of operations technology and IT technologies, you can now go into the process discussion within the manufacturing sector and the subsectors and seeing what is it that we are producing? How are we producing? Is there an opportunity for us to drive a different level of productivity, efficiency, safety, and resiliency that will not only add to my bottom line, but produce higher productivity? So I give you an example from our own experience at Nokia. We, few years ago, late 2014, early 15, some of the brilliant minds in our supply chain logistics and manufacturing segment, they had this vision to think about what a factory of the future should look like. And back then we were starting to think about what an agile, self-optimizing, highly autonomous manufacturing facility will look like. So we started to think about that. And right now we are running our factories with 5G private networks, edge enabled, with a lot of advanced analytics and a number of other things. And to drive the following: extreme robotics automation using software-defined reprogrammable machines that can dynamically orchestrate and accomplish certain tasks. And that has been massively helpful. As you can imagine, in the pandemic, you were remotely able to do a lot of functions without any downtime because of the high performance, reliable connections that we had. We were able to use 5G also, the 5G private networks for multimodal sensing for safety, meaning geolocalization and placement of equipment. So for example, if a forklift needs to carry a heavy payload in a factory, and if a human is close, you need to work at a safe speed. But if human is not close, you can work 3 times the speed. So you can improve the factory production and that stuff. We were able to implement high fidelity digital twinning services using augmented reality applications, meaning now you can remotely diagnose, assemble, manipulate tasks through human augmentation. Now, because we wanted to now have humans and machines collaborate in a way, in a safe and a highly productive way. And again, 5G in itself was offering the base fabric for that. And here's the interesting point. By doing all of that over a course of these years in the transformation, these sites that have implemented this have seen a 30% year-over-year productivity improvement, an 80% reduction in production lead times, and a 20% reduction in floor times for staff, and that has reduced in terms of safety incidents. So all of them you can see has an impact in terms of the efficiency and the productivity and the resiliency of the sector. So again, I would go back to the notion if 20% of your GDP is driven from manufacturing in Turkey, and you are doing 30% of exports, is there, and I don't know how much workforce population you're employing, by creating the augmentation and by creating a highly productive environment by utilizing the 5G set of technologies, you can actually change the game for that. And I think there's no better time to rethink and relook at that, because what pandemic has shown us that the proportional impact of different sectors, because as you know, there's a lot of discussion around supply chain shortening the supply chains, discussion around trade and whatnot. So every country now has an opportunity to reset itself, think about what sectors and subsectors are important, which sectors I should onshore versus offshore, because not everything you need to panic and say, I need to reshore everything. There are certain sectors which would have a big proportional or disproportional impact to the economy. And therefore, the implication of and the impact of 5G has to be really thought through from the automation and augmentation of the use case. So this is why I think manufacturing is certainly a very good sector to think about in terms of its application for your economy itself.
But I basically wrote down 30% productivity gain, which is mind-blowing. I need to dig deeper into how that's achieved, because I think that is of importance to everyone listening to us today, because achieving 30% productivity gain in any manufacturing site is mind-blowing. Having said that, knowing the background, I want to tie this discussion into this private LTE or private networks or private 5G for a while. And then we have a question I would like to, in the meantime, you can have a look at that question as well, and let's answer that as well. But Hari, you mentioned this private networks. What is a private network? What does it mean? Because, you know, we're used to Wi-Fi. It's something that in the technology domain, we know that we just buy the routers and install them. And then when you say network, it's a mobile operator's business. So what is this private network?
Indeed, that is a new topic in terms of deployment, because historically 3G or 4G network could only be deployed by the large mobile operators. And now first time with the history, it will be possible and has been now possible that you can make a fairly small local dedicated network. And what is needed for that is the underlying technology, which can scale down so that you can make a small network. And also what you need is to have the spectrum, so the spectrum options for deploying that. And both of these things are now happening. So you can see in many different countries, there are spectrum blocks available, which can be used for the private networks. And then secondly, vendors like Nokia are providing a solution which allows you to do like a simple local deployment. And the motivation has indeed been the reliable connectivity. In many cases, mobile operators are not ready, or maybe are not willing to make a kind of a local deployment. They are not willing to add more base stations. And what you can do with a local network, you can have full control of the radio design. But then secondly, you can also have a full control of your core network and your applications, which means that you can keep everything in your premises, which is of course important from the security point of view. And I think security was also one of the topics mentioned here in the Q&A. So overall, you could say that that 5G radio is not alone enough. Typically, we need to have some other kind of important pieces of technology. We need to have cloud computing, and we need to have the artificial intelligence combined together. And indeed, these are all coming now pretty much together in terms of like private network deployments. And if you look at the local market in Turkey, then Nokia recently made a deal with Arçelik together with Turk Telecom to provide Turkey's first 5G ready private wireless network. So it's not only something which is happening somewhere in in other locations, but it is indeed now starting to happen also locally in Turkey.
So how widely adopted is this one? I know that especially in Germany and automotive sector is really going for it, but how many installations do we have globally, not in terms of Nokia, but in terms of private networks? What is the rollout numbers?
I think there are, we have a few hundred, totally, of course, the number is bigger, but you could see we are fairly early phase here. Remember that 5G today has been mainly deployed for the mobile broadband by the mobile operators. And only right now we start to have the pieces of technology which are needed for the private networks. We need to have the 5G core network, we need to have the local edge, we need to have the small base station solutions, and these are indeed only right now becoming commercially available. So you could say the market is indeed right now starting globally.
I can add a data point, Utku, to this one. A couple of years back, we did commission a study to figure out, because remember, I was talking about that this physical industry segment, manufacturing, logistics, all of these guys which will need private networks is where we have to digitally augment them. That's where the private networks need would come in from. So what we found out that today, the total number of macro base stations, the typical ones that we have, the number is 7 million. By 2028 to 2030, we are looking at almost double the need when it comes to local networks, which is this mission critical private networks that Harry talked about. So you see the opportunity size ahead of us is 2x. 7 million is today in terms of macro base station. 14 million is our estimates, because that estimate is coming from what the ports would need, what the manufacturing would need, how many small cells, how many local sites you have to build. So you see, we are almost at the first hour of the transformation that we are starting, and it's a massive transformation ahead of us. And the imperative again is very clear, because these industries have to now move beyond a wide tethered infrastructure that they have built over the years. Now they need to drive towards those productivity gains. In that case, you have to untether them. You have to have a wireless setup. You have to have a cloud-based setup. And for that to happen, you have to build these private networks. So the opportunity horizon is there.
I mean, the way I summarize this personally is that, back in the day when the internet started, the normal businesses didn't necessarily care about internet. Then we saw the rise of e-commerce, and then all brick and mortars had to care for e-commerce, and they had to become digital as well. And the way I see this is that right now nobody cares about private networks on the manufacturing side. I mean, not nobody, but it's not a wide known phenomenon, but you put this number quite astonishing, 14 million. But just in a nutshell, in the near future, I think all the manufacturing sites will need to care for 5G and private networks if we are talking about IoT, sensor data, quality improvements, and productivity improvements that you were mentioning, Fuad. So yes. I think that's very, very, how can I say, the early days of the adaptation. But countries like Germany, for example, have been making these frequencies available for the newer applicants, not only the mobile operators. So we'll see probably more and more countries adopting this. Maybe I can ask Harry, if you know on top of your mind, which countries are, or for you as well, which countries are promoting this private networks in terms of spectrum availability?
Indeed, Germany made the decision that on the 3.5 gigahertz band, there's totally, remember, 400 megahertz, and Germany decided that 100 out of 400 will be allocated only for the local use, which means that 300 was allocated for the nationwide mobile operators. 100 is something which is available then locally. Another example is Finland, my home country, where the regulator decided that part of the millimeter wave frequency, that is so-called 26 gigahertz band, has been also allocated for the local use, and that is even 800 megahertz in total.
Thank you, Harry. Maybe I can switch gears and try to answer the first question. I don't know, Harry, if you can see the questions, but the first one is coming from Erman Thailand. I'll try to read it out loud for you. what will be the new business models that 5G will bring in addition to the existing, in addition to issues such as network architectures? He says, in my opinion, such as security and management of big data and remote working applications will be much bigger.
Yeah, I think it's a great question. I think I'd like to answer it from the perspective is you got to understand how the landscape is changing from a competitive perspective. So case in point, look what is happening right now. If you look at the competitive landscape, the number of players that are playing. So the telcos who are clearly the pioneers, the drivers of building 5G networks, they have made the investments in 5G. Now they're looking at opportunities to monetize, and that's where they're figuring out what the business model is going to look like. For that, they are sometimes trying to spin off their non-core assets and figuring out how they can use their investments in 5G, offering managed private networks, offering slicing to these enterprises to figure out if they can create value, and if they can create value for the end enterprises, how can you then capture a slice of that value? So I'll talk in a minute about that as well. But beyond the telcos itself, you are seeing that the web scales are also getting very excited about this opportunity, because now you see they're making very bold moves into the local premise by building these edge clouds. So that's, again, a component of what I call the 5G plus architecture, a suite of technology, because 5G is built around edge clouds. Tower companies are saying, okay, we have proximus local locations close to the different activity zones. Why not we transform ourselves into some sort of intelligent infrastructure company? We have enterprises, as you rightly said, who are building their own private networks, because as they get the spectrum, they are saying, we have needs, I can build my private networks. And then application providers who are very hungry to get exposure to this underlying 5G networking capabilities, because for the longest time, they didn't have a platform capabilities offered to them with the way our web services have been working in the past, exposing APIs. So when you look at all of this, you see a lot of shift is happening in terms of the playing field, and a rejigging of the business models are happening. So what we do see is going to happen is there is a rising trend of moving away from upfront CapEx type investments and buying investments in what we call a co-opetition model, whereby whoever is providing the service for the entity who you're providing the service, the idea is to drive for an outcome-based service level agreements. So for example, if a factory or a port in Turkey is offered a private network solution by a telco, and you work hand in hand with them, then you're driving a certain revenue enhancements or a productivity enhancement. You can then slice a share of that back to a providing entity. So you see there's a risk and reward mentality that has to be coming in. It's not there today, but that is the big opportunity for these players to collectively work together, because all of them, this is not a game that can be played by one. It's a team sport. Everybody's bringing something, but the players' roles are changing very frequently and dynamically. Traditional competitors are becoming partners, partners are becoming competitors. So the business model innovation, what I call is to balance out value creation and value capture. You have to look at the end user, in that case, a manufacturing facility. If I can help them increase a 30% productivity year over year, I better be entitled to get a certain proportional in return. And that is the opportunity. It's not an easy thing, but if we can demonstrate the value of the underlying networks to be able to automate and augment their processes and drive the overall value, then I think you can sort of balance out value creation and value capture. So that's how I see it in terms of business model opportunities.
What about you, Hari?
So
in terms
I
of
think
industry,
this,
we've been talking about manufacturing.
yeah, so
really good case, but what else?
I think this, I mean, what we have seen already, one important example is the kind of like public safety communication, and that is like government communication, firemen, policemen communication, and the case is simple that kind of communication used to be running on top of dedicated networks, but those networks, like Tetra networks, did not have data or video capability. And now what we can see is that that kind of communication is migrating on top of 4G and 5G networks, and the benefit is that then like the policemen or firemen, they are able to use like video connectivity, which is of course important for any kind of like safety applications. Also, typically what is combined there is drone control. Drones are quite important application for any kind of emergency cases, or if you want to have some surveillance on the mass events. So you could say like public safety, drone control seem to be one like very, very practical examples. And that is also explaining why the critical or the quality of the network or the critical communication is becoming so important for the mobile networks now.
Thank you, Hari. So manufacturing and public safety are two hot topics from your perspective. There's another question which is very interesting and rightful coming from Pınar Köse. What impact will we see on the backhaul with 5G? Will 5G require more fiber, and will lack of it be a showstopper for 5G success? Hari, do you want to
Yeah, so I mean, fiber is of course beneficial for the 5G deployment, but it's not mandatory requirement. And let me take some examples. If you are rolling out 5G base station on the mid-band frequencies, that is able to provide a number of users simultaneously with a 1 gigabit service level, and therefore in practice the backhaul connectivity is designed for 10 gigabits capability. So 10 gigabit Ethernet is typical backhauling for the 5G base station. Fiber can be used and is typically used for that, but we have also a number of customers who are using microwave point-to-point radio for the transmission. And like in Saudi, we have a number of big customers in Saudi who are using the microwave radio for the backhauling. So it is feasible also without having fiber to every site. If we then want to go even beyond, we have some customers who are using so-called centralized baseband, where the idea is that they have remote RF heads and they want to centralize the baseband location. In that case, we need more capacity because that is so-called front haul. And then we need typically 25 to 50 gigabits capability. And of course, for that case, then fiber will be mandatory.
Thank you, Hari. I'm just also taking notes. 50 gigabits per second per base station looks very, very different, because when I started my career back in the day, we had 2 megabits per second per base station. That was good enough.
E1 connection, yes.
Yeah, it just reminded me like, okay, it's like the dial-up, you know. When we started the internet, it was dial-up, and we're talking about gigabits per second per customer, and things have evolved. It's mind-blowing. So I'll move on to the next question, again on technology, and then I'll tie Kerem's question to, you know, the business and socioeconomic impact of 5G. But Müge is asking, what will 5G private networks or 5G in general provide in terms of manufacturing data security? I think this is also a strength of 5G, but maybe Hari, you can take up on this one as well.
Yeah, maybe I can start. What can continue. So so basically, in terms of technology, the solution is that the radio connectivity or the radio part has extremely good like encryption, and that is part of the basic design of the system, which we didn't have in Wi-Fi. And then secondly, also in the private networks, you have full control of your solution, meaning that you don't need to take your data to any centralized core network or any centralized location, but you can keep the data in your premises. So indeed, you can combine a radio interface, encryption, and you can combine the local data for high security. But maybe Fuad can also continue on this security topic.
Yeah, so. I think you're right. I think first of all, look, understand something. It depends on the use case. If there are use cases which we can actually satisfy pretty much in the special area or a local area context private networks, it's great, because you essentially have a layered architecture, because the bottom layer is the network has virtualized itself and offering itself as a service. It's residing using a PaaS layer, either from a web scale or a telco cloud provider, where all the cloud network functions are being hosted. So things like location management services, cloud management, security management services. So all they are sort of operating in a pretty tightly managed control way because they use the underlying the foundational layers of the 5G network. So in that case, it's pretty self-contained. You have everything you need, and you start to, as you start to bring new use cases in a local context, you can start to add those use cases. Those use cases then can be created different slices within the context of the private network through the different domain layers, where there's transport, core, radio, and what have you. So that can be easily managed. But in the case of logistics that I was talking about, because remember when I said once the containers have been moved off of the ship onto the trucks, and now the truck platoons leave the port into the mainland, you are now in the wide area network. So in that case, you then have to figure out a basis of how the private networks and public networks have to interwork together. And that's where the new security principles have to be looked at, whereby not only the underlying cloud infrastructure and the mission critical networks have to be secured, you need to go above and look at the entire infrastructure, looking at devices, virtual machines, software, hardware. You have to think about basically the data access identity federation, that it has a trusted setup in itself, and then this notion of orchestration amongst and management, because if you're moving all these network elements, you need to have a very frictionless dynamic setup. And then finally, this security intelligence of it, because you want to be preempt the threats before it's emerging. And in the context of distributed nature of the 5G architectures, whether it's private or public, and you have all these different edge cloud instances that will be springing up. So imagine Turkey being divided up into every 50 to 100 kilometer radius, you have an edge cloud instance. So if you can basically move your cloud network function or security appliances close to these edge cloud locations, the working of these nodes amongst themselves or interworking of these nodes can give you a very distributed new policing mechanism when it comes to the new 5G security architecture itself. So I think it is something, as we start to digitalize these physical industries where operations technology and IT collide, we do industrial IoT, the threat surface changes, and therefore the private networks and the interworking of private and public networks based on sectors and use cases are going to basically be profoundly important. And the architecture itself allows us to do that, because then we will be moving this in a frictionless capacity, all this security intelligence out at the edges, and then harmonize it accordingly. So that's how I see it, the security aspect of this particular technology.
Well, thank you very much. When you say security, I always think of quantum computing, because that's where I think the paradigm shift is going to happen in terms of the network security. Whoever going to get the quantum computing first is going to have an entertaining day, I must say, in terms of security. But having said that, there are a couple of questions. I'll pass one of them, but I'll tie the conversation to the larger impact of 5G, because we started with 5G is not another G, and there's a global competition going on for the 5G. But before going on to that macro question I have in mind, there was a question about whether we need fiber to the home in selective urban areas. I believe that's not, I mean, that's a general question, both specifically for Turkey and the global, but I know the answer. So I would say, yes, we absolutely need those as well. These are complementary technologies. 5G is not going to necessarily eliminate the need for fiber to the home. That's my perspective at least, but if you guys want to take a step.
But I think, so there is a certain, again, technology is not always about technology itself. There's economic reasons and deployment timelines and different difficulties. And therefore, one of the use cases, the early use case of 5G is what we call fixed wireless access, right? So fixed wireless access can also offer pretty reliable kind of service. I wouldn't say fiber-like, but close enough in terms of making sure that if you look at the different zones within Turkey, where you can roll out fiber economically and technically in a viable fashion, that's perfect, that's great, you should do it. Where you can't, you can look at fixed wireless access technologies to make sure that it gives a better economic and a technical answer for that. So I don't know, Harry, if you have any thoughts on that.
Yeah, I think 5G now can provide quite nice solution for the home broadband connectivity up to a few hundred megabits per second, and that's what many of our customers are doing today. If you look at back in the history, even LTE 4G network has been used in some cases for the fixed wireless, but the problem was that we are easily running out of radio capacity. I mean, if there are a number of households simultaneously using video connection, the 4G LTE capacity was not enough. But now, when 5G will bring roughly 10 times more capacity, then the also the fixed wireless communication is becoming more feasible on top of 5G radio, and that is what many customers are using today. It's maybe not always in dense urban area, but maybe more typical case is suburban area where rolling out the fiber is simply more expensive. And then, like Fuad is telling, then in that case, the radio solution, 5G solution, may be more cost efficient compared to digging the fiber connectivity.
Thank you, Harry. I'll ask the next question, but I couldn't understand Berkan's question. I couldn't understand whether applying 5G to robotics or not. So I'll ask him to rewrite the question. But I will tie this to a bigger subject now, because we talk about 5G, and we also know that there are some even global discussions. You know, we've seen what Donald Trump did in terms of the 5G stands, and there's a global race. You can just type 5G and global technology race. You see a lot of articles about it. But what does it mean for countries like Turkey? How do you see the 5G will help both in terms of adaptation of 5G, but also, as you know, how we discussed, there are some activities in Turkey to have our own technology capabilities in 5G and so on. So taking both lenses, where do you see this competitiveness of such countries like Turkey will unfold with 5G?
Yeah, I think the first part here is simply more capacity, more data rate, which you can also turn into maybe better productivity, better capability for remote working, better entertainment. But indeed, the more important factor is that 5G network will be the underlying communication solution for the critical connectivity, and that is exactly like how you can boost your productivity, how you can boost safety in the country. So these are the two important aspects here.
Thank you, Harry. So Fuad, from an economic perspective or global competitiveness perspective, especially around Turkey.
Yeah, I think you're right in saying 5G has almost become a brand thanks to some of our the big players in the markets, and we've seen and hearing a lot about 5G. But I would go back to the fundamentals here, which is in the context of Turkey, what's important, right? If manufacturing represents 20% of your GDP, you better give it a serious consideration around how do I augment that industry? And when I say augment, the power and the capabilities of the 5G and associated technologies have to be rendered to the manufacturing capability of Turkey. So if instead of 30% exports and the contribution you're making today, how can I do a step change of that? One thing I would like your audience to really understand is that, again, we've talked about this, don't think of 5G as a point radio technology. It is, and in fact, I'm happy to share a paper with the audience, and maybe you can share that, Utku. We talked about 5G and associated technology because we call it 5G plus. And the reason is we've talked about this notion of edge clouds, which are going to be strategic asset for you because most of the intelligence is going to collapse there. So the application devices, all of them, and the network will essentially come together at the edges of the network. And that's why it's a big shift in terms of how we have built networks in the past, where it was largely centralized with command and control structures, right? Where there's a central brain controlling something. Now think of it as mini brains at outposts that are making autonomous decisions, AI-enabled decisions, and that's the fabric of the 5G network. So what it means is, if the future of 5G and all of these will be massively distributed, localized, and software-centric, which means it is by nature pretty local, not because of nationalistic interests, just the way technology has evolved itself. It has gone from being centralized, where data centers were thousands of kilometers away, where we had built web services in the past. Now everything, every city perimeter, 50 kilometers would have a edge cloud data center in the future. So your future competitiveness is going to be pretty much governed by the fact that how you are driving and building your edge cloud strategy, around which you're building your 5G networks, and proximus to where your industries are. So we talked about manufacturing, we talked about the future of logistics, and I can also talk a little bit about agriculture, if that is important to Turkey. I mean, case in point, I mean, look at the projections by 2050, United Nations estimate the population is going to grow to 10 billion. And what it means that our industry, the food industry, the agro industry, has to find ways to produce 60 to 70% more food than it's doing today. But in the context of today, we are wasting a lot of food. 10% of the food we produce gets wasted. 1/3 of the food we produce gets wasted. 10% of the population go hungry. So at a local level, at a regional level, what you need to figure out is, what is it that I can do with the power of the new advancements of technology to produce emerging use cases in agriculture. So one example I can give you is what we call precision farming, which is a method to use wireless remote monitoring, private networks, AI-enabled analytics to drive higher yields in the capacity. And my team at Bell Labs Consulting Macroeconomics Practice, what they have estimated is that if you are able to convert your 15 to 25% of farms can adopt precision farming, you can do the following. You can increase your yields up to 100 million tons. You can reduce your farming cost by $100 billion, and you can reduce the water usage by 150 billion cubic meters annually. And that's a big thing at a global level, because what you could end up doing is you can set in motion a transformation for the entire food industry. But here's the problem, Utku, is that what we have been doing in the agriculture sector are using point technologies to solve for point solutions, meaning that we hear, let's say, a news that we have used an AI algorithm to look at a crop quality. It's great, the algorithms is doing that, or doing crop picking. But what we are missing is, how do you bring into fold the promise of 5G and associated technology and the constellation of those technologies to drive for global scale? Because once you have the capabilities implanted in the agro sector, now you exactly know how much food to grow, where to grow, how much to offer, and what kind of precision I need, and that will have a big connotation effect, or the implication to the local economy. So think of agriculture, think manufacturing, think logistics, and don't get caught up, what I say is, on this consumer thing, because consumers have always benefited when technologies have had a industrial application to it. The example I gave you on the first and second industrial revolution, we did massively well, and of course consumers benefited. But where we got distracted when consumer got in charge, right? But now we are going back to after the pandemic has come in, we realized, because of all these different factors, social, political factors, technology factors, we better rethink. So if Turkey wants to go into 5G, yes, we have a consumer angle, but you got to take a very serious look at industrial and human industrial transformation impact of that. Because for the first time, the technology allows humans to augment itself and work with these industries. And that you would also see has an implication on jobs of the future. And we can talk a little bit about that, time permitting, but we have a very strong view of how the jobs of the future will evolve around the 5G ecosystem.
Thank you very much, Fuad. It's very important that, again, you keep on pounding that, but like consumer versus industries, I think that's something to take a deep note about it. There's some couple of questions. I will just go to questions. Simply, basically, they're asking if 5G has an impact on artificial intelligence development. And also, I'll ask two questions at one time to save time. Maybe Harry can answer this. And also, what are the calculated effects of coming 5G transition in terms of environmental topics? Wow, this is very important. Again, in terms of the environmental sustainability, the planet that we're living in, will 5G have a positive impact? And I hope that the answer is yes.
Yeah, so important topic. So first, the artificial intelligence. So there are a few levels here. So first of all, we are using AI for making the networks better. So we are using that on the physical layer, even inside the base station. We are using that for the power saving techniques. We are using that for optimizing overall the network KPIs, key performance indicators. But then secondly, of course, what is maybe even more important is that 5G allows you to collect a lot of data, which you can then process in the edge cloud with the AI solutions. And that is one of the reasons why Nokia is working quite close with the companies providing edge. So Nokia is working with the AWS, Amazon Web Services. Nokia is working with the Google Cloud and also with the Microsoft Azure. So the idea is that it's not that we are doing everything alone, but of course we are collaborating on the other key players here in the industry. Then the second topic was about the environment and CO2 emissions. And first of all, you could say that 5G radio is the first radio technology ever that has been designed for minimizing the energy consumption. Earlier, in the earlier technologies, the idea was that we simply try to make the components more efficient. But in 5G, the energy efficiency is kind of inbuilt in the system design. There are, for example, power saving solutions available, which means that even the base station can use power saving techniques. Earlier, it used to be part of the mobile devices, power saving, but now similar kind of power saving techniques can be also implemented in the base station. And where are we today in practice? We did recently a study with our 5G base station showing that the energy consumption per gigabyte is roughly 90%, so 90% lower than in the 4G, so 10 times lower. So clearly, if you want to provide more capacity, 5G already today is substantially more efficient. But that is not enough. Our target is that our 5G base station will have 50% lower power consumption by 2023 compared to where we are today. So the target is also to make our products clearly better because of better hardware, better chipsets, better AI solutions inside the base station. So clearly, it is very important for us and for the industry.
Well, I'm very pleased to hear that, and I hope that we'll catch up, because there's not much left in terms of the overall sustainability of the planet. So I think this is also a big step for the telecom industry. 90% is huge, but I know that also the consumption and usage increases. So it kind of like maybe balances out because we are consuming much more data.
That is correct.
Still, 90% is a drastic saving. Having said that, I don't know, Fuad, if you have anything to add on it. Otherwise, there's another question about use cases. 3 aspects, because I think these are also manufacturing use cases. A question related to return on investment prioritization. Which of the below 3 aspects are more likely to provide more return on investment? Broader band for product tracking and monitoring, including computer vision, low latency, autonomous transportation and logistics, and massive data acquisition for advanced analytics. So if you were to pick which one has a better ROI from a 5G investment perspective,
yeah, I think it
is there a clear winner?
No, I think it's difficult to say this or the other, and the reason is very simple, because you got to understand the starting point of these industries and how they're using what is the present mode of operation that they're running. And when you overlay or look at the alternatives, then you need to figure out will the ROI stack up, etc. Right? So somebody has made certain investments in certain technology. What is the life cycle of those? So there are a number of factors that look at it, but clearly. We have, when we looked at the industrial case on the ports and logistics, we clearly saw a very strong business case because of the notion of automating the port operations. We had looked at also, what was the other case that was mentioned, Utku? Sorry, on the question.
There was 3 broadband, like broadband throughput,
Yeah.
latency, and massive data.
Yeah, and again, when you look at the use case requirements that this particular customer gave us, let's say they said by 2025 I need to do a bunch of these things, automating my cranes, managing my vehicles, managing people communication, sensor data, all of that. That translated into pretty much this throughput requirements, latency requirements, reliability requirements, and therefore what we said is, where are you today and what you need to do? But we looked at a very strong return of investment because they had a future perspective, not a very short-term perspective, or because I can then just deploy a Wi-Fi to fix a point solution. That was not the case. So it depends on the ambition levels. If you take a longer-term view to value creation and you multiplex the requirements of different use cases, then your ROI composition and the answer would come out very differently. And in fact, would be much better in the long term, much more sustainable, because then you are not in this risk of just upgrading and doing things in an ad hoc way. You are actually then building the requirements in a more holistic sense and building the future foundation of that for enabling or automating these use cases.
Thank you, Fuad. I say when I'm asked this type of questions, there is not a silver bullet in these type of technology investments. It's a team effort. So all of that needs to come into the picture to make the business case just right, especially for the private networks. But all in all, I think you are right that there is
one thing I would just say very quickly is that we're entering a pretty interesting time, because most of the businesses and industries are realizing that beyond their own profitability, there is a very strong purpose that they have around national growth, economies, and their overall implication to the decisions they make. And in that context, the formulation is becoming very interesting. It's not only just the shareholder returns only, right? Yes, it's a very critical and central part, but to your question earlier about the competitiveness, the future positioning of different countries, and how do you play the game, I think you need to balance out all of these things as you start to look at investments in future technologies that drives this transformation.
There are some final questions that I'd like to convey. Turkey is considering to launch 5G in 2003. Do you think it's a realistic target?
2023?
Yes.
So again, from whose perspective? Is it launching for offering enhanced mobile broadband to consumers? Or I think realistic, I don't know, how would I read that question? Because again, if I was to go back on the narrative that I'm sharing with you, I think you guys got to start early planning, because if you want to look at your this obviously augmentation of your consumer side of things, which is fine. Maybe, I don't know, the investments that have been made, what is the service level agreement, the internet penetration, all of those things is one thing. But I would encourage you to start thinking 5G more holistically and broadly in the context of the industries. And maybe 2023 is, you need to maybe pull it up in the sense that start the planning now. Talk to your industry stakeholders, because you got to bring this consortium together early, and which is, I think, hats off to you, Utku, and to TÜSİAD of thinking about this, because there is no better time for industry, business, technology providers to come together so that the application of that can be well understood, and we don't start to go back to the point of incremental transformation, but think about this broad wholesale level of changes and the actual implication towards productivity. And in that context, I don't know, 2023 is realistic or not. Maybe we should start early and do it earlier in terms of the planning, and see what is required for us to be ready. What are the use cases? What are some of those constraints that might inhibit Turkey's ability to spearhead in this direction, etc.
There are some further questions on this one. They say the government announced it recently about the 5G developments. Berk has asked, what other 5G use cases might be possible in the far future in vehicles, apart from technologies such as autonomy and connectivity?
Indeed, one topic that has been defined in 3GPP standardization is so-called V2X, vehicle-to-vehicle communication, vehicle-to-network communication, where the idea is that the very same 5G radio solution will be utilized also between the cars, so car-to-car communication. And the application could be simply kind of providing information like safety information, like security information, some kind of like automatic braking information between the cars. The other use case is that you can have connectivity like from the like traffic signs or lamp posts to the cars, like providing information about the local possible like dangerous cases or hazards. So indeed, that is now on the table, has been defined in 3GPP.
So basically, cars will be like base stations, if I understand correctly from your comments.
Well, not exactly. You know, you're not exactly base stations. So the base stations will be. I mean, you can utilize mobile operator base stations like today. Secondly, you can have dedicated road sign base stations. But the cars have the normal connectivity to those networks, and additionally, cars can have like direct communication between each other. Is you could say like a walkie-talkie type of communication in the early days. So two mobiles connecting to each other, and that is indeed being defined for the like, for example, for the safety applications.
Thank you, Harry. There are three more questions, and then I think it's about time we start wrapping this up. So if there are any questions that needs to be published, please post your questions. There is a question about 6G, but I will give you as the last question of what's next. So I'm parking that one. But Orhan is asking, could you please elaborate on the health and safety concerns the public might have on the extended usage of cellular networks, particularly 5G? Do you see this as a potential threat ahead of the adoption of 5G, private 5G especially?
Harry, you want to take that?
Yeah. So basically, I mean, 5G is not changing anything compared to what we have in 4G today, and we are following the guidelines provided by World Health Organization, and basically the radiation we have is non-ionizing, so the impact that the radiation can have is a thermal impact, and typically the guidelines are defined so that there's at least 50 times lower limits compared to where you have any impact, and that is how the deployments are designed, and that's how the products are being designed. So there's a clear margin compared to any kind of potential concerns here, and nothing is actually changing compared to what we have 4G today. So,
Harry, let me ask you another question about this one. Do you think that there is another reason why there's so many conspiracy theories or fake news about 5G? Do you see any particular reason for why that's happening?
Oh, I mean,
I guess
there's no specific.
You might not have an answer for that, but
yeah, but I think it's always like a new technology. I mean, you can. I mean, if you look at underlying technology, then you can explain that there's really nothing changing in that aspect. But I mean, it's always like a new topic which people are not familiar with. So I guess we simply need to distribute right information and make the audience or make the public aware of the facts behind, so that everybody can trust the part here. And also we need to remember that 5G itself will help in terms of safety, because like many applications we discussed today, they are important for the practical daily safety of the people's life.
Thank you, Harry. There is a question from Kerem Fındık. One more question. Are you in touch with the Turkish authorities in launching 5G? Maybe not you personally, but from your firm, or as much as you know about the 5G deployments in Turkey?
I'm not 100% aware of the details, but I'm pretty confident that the Nokia local teams would be discussing with the relevant stakeholders. But I would encourage the association and its members to also think from their perspective, based on the discussion that we had today and otherwise, in terms of your requirements and your needs, that should come together with the likes of Nokia representatives to build a stronger case towards the regulators and the government around the need and the timing of this transformation. And I think that's an important step. I think that's a really good question and something that has to be looked at.
Thank you, Fuad. I'll ask the final question to both of you, and I want kindly you to answer individually, but two questions in one. What's next, and what is your key messages for the audience, knowing that the audience are key industrialists who are listening to us, and there are some media as well.
Yeah, so maybe if you first look at what is next year, so remember that 5G today is in the very early phase, even globally. And if you look at the next steps today, we have basically mobile broadband available. The critical communication, private networks are only starting today. And what are next steps beyond that? Now, this industrial IoT clearly will be the next big step that is going to be available widely soon. The next step will be so-called, you could say, like a wider adoption of 5G radio for many other use cases. Other use cases could be like the car-to-car communication. It could be so-called non-terrestrial communication, meaning that you can have 5G radio connectivity to satellites or high-altitude platforms. And also, there is an evolution to use the same 5G radio for the low-cost and low-power consumption IoT devices, so Internet of Things connectivity, low-cost, low-power consumption. And in terms of evolution, the next step will be so-called 5G advanced, and that will be available in 24-25 timeframe in practice. 6G, of course, will eventually happen. We believe there will be again a new generation. Nokia has started the underlying work for that, and Nokia is actually heading the European research work called Hexa-X. So the underlying research is starting. And if you give one example, what is going to be the new thing is RF sensing, meaning that the RF we are using today has been used for the communication, but then the idea is that the high frequency RF you can also use for sensing, like identifying how the people are moving, using that for the personal kind of health application as well. And maybe that will eventually be commercial. If we are talking 10 years later, maybe we are talking about those 6G applications by that time.
I'll be more than happy to host a session on 6G in 10 years as well. So for your
and I think the prerequisite for that, Utku, is you got to first look at augmenting your physical industries or digitally vaccinating those physical industries first, because that forms the precursor towards the 6G growth. Because what we are doing in 5G, we are trying to bring our physical and digital worlds closer together in 5G. And in 6G, we'll add the third dimensions of the biological and the human systems and all of the stuff that Harry talked about. So I think that's important. But I think for me, the important thing is, again, it's an interesting point that just came to my mind, which was made by this famous economist, Paul Krugman, who said, productivity isn't everything, but in the long run, it's almost everything. And if you think about it, there's not much in human existence that hasn't been about productivity. We've built things in a way that has allowed us to do things better, the rate of production, the rate of doing things. And that's why, for me, the key topic is to think about enabling your industries and enterprise to be able to do things more productive, be able to deliver with speed and scale, because that's going to be a new imperative. And finally, understanding the changing trends, because we are going away from the time of mass production to a time of mass personalizations. So if you are doing mass personalization, you better have a pretty good sense of what your consumer wants, what your enterprise needs are, and so you can tailor and adaptively manufacture that stuff based on that. You are moving from the habit of buying upfront to pay as you grow, meaning outcome based. So you better come together with that cooperation model where industry actors work together in a way that can complement each other and augment each other to drive for value creation, and as a result, create that value capture. And you're moving away from the era of manual operation to an era of augmented operation. So once you do that, you got to look at how that impetus is going to come from. That impetus in our mind is going to come from the investments in ICT, which is by 2030 accounts for 6 trillion. And we believe 5G plus enabled ICT spend, which is 5G, edge clouds, AI systems, robotic sensing, will amount for 75% of that spend. So you see there's going to be a big inducement effect of that. And the final takeaway for your audience is that the new economic formulation will be based on 3 things. One is that once you have done that inducement and the injection of the capital and build that 5G plus infrastructure, you would see more profitable industries and enterprises because of safety, productivity, and efficiency gains. You're going to be creating new jobs and better jobs and different wage structures, which have a different effect to your local economies and regional economies. And finally, you'll have a different revenue structures for governments, because if governments are going to institute better competitive policies and institute incentive structures that allows you to equalize the playing field, I think that will be a big opportunity. So with that economic value equation, you're going to have a big contribution to your GDP itself, and your local competitiveness and the global competitiveness itself. So that's really what my takeaway is as terms of next steps, and we have to be prepared and plan for that.
Thank you very much, Fuad. Hari, Fuad, again, it was a pleasure to have you with us today, 2 gurus of telecom globally. I will basically summarize what you have told to us in layman's terms. So you know 5G in a nutshell, it's faster, better, cheaper in a way. But more than that, I think you opened my eye in terms of 5G is not about the consumers, but it's about the industries more. So the industry should take the moment and really understand what might be the implications of 5G in terms of their global competitiveness. I think that was key. And especially not even maybe waiting for 5G, but from the private network perspective, we need to look at this more seriously going forward. But I'm also very pleased to hear that 5G is going to be much more sustainable from the planet's perspective. So it's also music to my ears. Again, I want to thank you and also our listeners for attending our first Digitalks webinar series hosted by TÜSİAD. We'll be with you with another very exciting topic, hopefully in the coming weeks. Thank you very much, everyone.
Thank you very much for having us.
Thank you.